Hello and welcome back to another episode of Math with Son. Today we're going to be talking about the main kinematic equations that you're going to be using to solve for motion. So, you need to know some symbols first. First off, anytime you see a VI or a VF or an AI or an AF or anything where it's got an I or an F as like a subset, that would indicate initial, and V stands for velocity, and F would stand for final, and V would stand for velocity. Anytime you see this little triangle symbol right here, that would indicate that you have a change, or this triangle symbol is really no different than you saying the x value of the final minus the x value of the initial. Okay, so change in is x final minus x initial, and acceleration is denoted as just a. Now, these are with constant acceleration in the beginning. You better hope in the end that you don't have ones where you have changing acceleration. The change in time sometimes is noted just as t, but that would be the initial time, and you would take that away from your final time. Okay? So change in time sometimes is just called t, and all of the f's and i's and stuff are for final and initial, and anytime you see the change in or delta, that is the symbol for triangle, that would indicate that you really have more than one variable here. Okay? So let's get into the formulas. All right. So when given a problem to solve for an unknown quantity, first you need to figure out which quantities you got, and you have a lot of equations to dictate it. So because there are so many equations, we're going to talk about them, and we're going to write them down, and we're going to figure out when you use each one as we start moving through the problem. So if you have no acceleration at all, that means that your change in any x value is equal to your VF and your VI added together, divided by 2, and you would multiply that by the time, which kind of makes sense because if you have no acceleration, the distance you will travel, which is the x value, the distance you will travel, is going to be the average between your velocities. Let's say you started at 0, and your final was like 30 meters per second, and then you could find the average. If you would add them up and divide by 2, you would get the average of it and multiply by the time. That's not that hard to understand. So you take your average velocity and multiply by time. No displacement is going to be VF equals VI plus A times T. Now, what does it mean for no displacement? That means that you haven't traveled anywhere, okay? That means that you are in the exact same position as you were before, or maybe you just don't know your displacement either, okay? So sometimes you just don't know, and you are only concerned with your initial values and your acceleration. You need to solve for one of those things, such as time or acceleration or velocity, and you don't care about displacement. Easier formula. All right? The main two that we're going to be dealing with right now is the no final velocity versus no initial velocity, and these are as follows. We are going to have a delta x is equal to VI times t plus 1/2 AT squared, which the no initial value is going to be delta x equals VF times t minus the 1/2 AT squared. Now, on your AP sheet, you're not going to get that, unfortunately. You're going to get a variation of this question, or these formulas on your AP formula sheet. You will get this one. You'll get x equals x sub 0 plus, I'll even write it the way they write it, Vx O times time plus 1/2 AT squared. Now, the main difference between this is here, Vxo is standing for initial value. So Vxo means Vi. It just takes a little bit longer to write. Xo is standing for your initial position, and X would represent your final position, but you don't need the F there. Now, what is delta X? Well, delta X is your change in X. So if you were to subtract that X sub O over, you would have XF, the final, minus XO. Well, what is XF minus initial? Final minus initial is delta X. Okay, so these represent the exact same thing as the other one that we have. Okay, so I'm going to maybe focus a little bit more on the one that we're provided with AP, but these do make it a little bit quicker. All right, they definitely do. Now, the no time one, this is the one that's always the most annoying to deal with, but if you don't have time provided or you're not concerned about time, but typically if you don't have time, you are going to be using this one. It would be your final velocity squared is equal to your initial velocity squared plus 2 times acceleration, and then you would have your change in x, so you can either write it as delta x, or you could write it as vf squared equals vi squared plus 2a times the quantity of your change in x values, final minus initial. Okay? So, in order for these formulas to work, okay, some helpful steps that we are going to utilize when we start doing the practice problems, probably in the next video. To solve these kinematic problems, we have to write down the unknowns. You got to write it down and label your unknowns. Label your known and unknown. And unknown. Man, my pen is really gloopy today. Identify, after you've labeled your known and unknown, the unknown would be what you want. Then you have to figure out which of these 1, 2, 3, 4, 5, potentially 6, if you think about it in terms like delta x and versus like xf minus x0, technically they're like slightly different. Which equation you would actually use. So what equation or formula will you use? You need to figure that out. And then after you figure out what equation you're going to use, plug it in and solve. Which makes it sound much simpler than it actually is. But the hardest part for these is identifying what equation to use. And then being intimidated by the fact that there are 1, 2, 3, 4, 5, I don't even know how many I counted. There are a lot of different equations that you could potentially use. But they're not that bad. Don't panic. Don't panic. All right? I will see you on the next one. We're going to actually do an example of some of these things right here. Okay? So, until then, stay positive, and I will see y'all later. Bye.